Welcome to this video where we dive into the world of silica and explore its different types. Silica comes in many forms, but in this series, we'll focus on the ones most relevant to the adhesives and resin industry. In previous videos, we discussed the terminology first, then various types of silica, and briefly introduced fumed silica and precipitated silica, two of the most commonly used fillers in industrial applications. We also discussed how silica plays a key role in epoxy adhesives formulations, improving performance and enhancing critical properties. Further, we introduced crystalline silica and their properties, and also natural amorphous silica. Today, we're going to further discuss amorphous silica by introducing silica fume. So, let's get started. The second subcategory within amorphous silicas is byproducts, which includes both silica fume and fused silica. It is important to note that silica fume is distinct from fumed silica, even though the name sounds similar. These two materials have different properties, production methods, and applications. Silica fume, often referred as microsilica, is a fine powder made up of spherical particles ranging in diameters from 0.1 to 1 micron. This material is pozzolanic, meaning it reacts with calcium hydroxide in the presence of water to form calcium silicate hydrate, which is the primary binding agent in concretes. Thanks to, thanks to its high pozzolanic activity and fine particle size, silica fume significantly enhances the strength, durability, and workability of concrete, mortar, and grouts. It is commonly used as a supplementary cementitious material to improve the performance of concrete, especially in terms of compressive strength, bending, seepage resistance, and corrosion resistance. Silica fume is produced as a byproduct during the smelting of ferrosilicon and industrial silicon metal in high temperature electric furnaces. During this process, a large amount of volatile SiO2 and Si gas is produced. When the gas is released, it undergoes rapid oxidation and condensation in the air, forming fine silicate particles. This is the silica fume, which must be collected using dust removal and environmental protection equipment. Given its low density, it is often processed with special equipment for this purpose. Specifically, the formation of silica fume occurs when high purity quartz in a high temperature state is reduced. Approximately 10% to 15% of the silicon in this process vaporized and escape into the flue gas. The silicon vapor reacts with oxygen to form silicon monoxide, SiO, and this SiO gas meets cold air and it combines with oxygen to form silicon dioxide, which then condensed into small spherical non-crystalline microbeads. These beads are discharged into dust and collected through this specialized equipment. The entire reaction process is illustrated here. The detailed process of silica fume production highlights its role in enhancing materials such as concrete and its unique production method. So now let's focus on silica fume. The chemical composition of silica fume is quite simple, within 85 to 96% of it being SiO2, primarily in amorphous form. This high content of amorphous silica is the key factor behind its effectiveness, and it is often compared to volcanic ash in terms of properties. The carbon content in silica fume is minimal, not exceeding 2%, and its burn loss is typically between 1.5 and 3%. Silica fume has a specific gravity of 2.2 to 2.3, indicating its relative density. While silica fume is predominantly amorphous silica, it does contain a small amount of crystalline silica, mainly in the form of quartz. The amorphous structures and the particle size contribute significantly to the high reactivity of silica fume. In some cases, high quality silica fume can have an amorphous silica content of 98% or more, making it exceptionally effective in various applications. The surface of silica fume is very smooth due to its fine particles, and the particles rarely exist individually. Instead, they are often clustered together through electrostatic forces, forming flocculants or agglomerated structures. These agglomerates can have a significant impact on the way silica fume behaves in formulations. The particle size of silica fume is incredibly small, typically below 0.5 micrometer, with an average particle size of only 0.1 to 0.2 micrometers. This makes it much smaller than other materials commonly used in constructions, such as cements, fly ash, or mineral powders, with the particles being approximately 1/50 to 100 of size of cements. Its specific surface area ranges from 15,000 to 30,000 square meter per kilogram, providing a large surface area for reactions and interactions. Silica fume also possesses a range of chemical properties that enhance the performance of materials it is added to. For example, good insulating property. Due to its high purity and low impurity content, silica fume exhibits excellent electrical insulating properties, making it beneficial for applications requiring anti-arc characteristics. Reduction of exothermic peak in epoxy resins. Silica fume can reduce the peak temperature during the curing reaction of epoxy resins, which helps minimize internal stresses, shrinkage, and crack in the final cured material. Secondly, corrosion resistance. Silica fume is chemically stable and not relatively reactive, in which, for example, it cannot react with acids and alkalis. Its particles create a protective layer on the surface, offering enhancing resistance to corrosion. Improved mechanical properties. Silica fume's granular gradation helps reduces issues like precipitation and delamination. It can enhance the tensile and compressive strength of cured materials, improve wear resistance, and even increase thermal conductivity and flame retardant properties. 4. Improved wettability in mixing. When treated with a sealant coupling agent, silica fume exhibits excellent wettability with various resins. This improves its dispersion and prevents the agglomeration of particles during mixing, making it easier to incorporate into the formulations. Finally, its cost reduction role. When used as a filler, silica fume not only improves the mechanical and chemical properties of the cure products, but also reduces the overall cost of the product, offering a cost-effective solution in many applications. These properties make silica fume a valuable additive in various industries, including concrete, adhesives, coatings, and epoxy systems. Thanks for your attention. In this video, we have briefly looked through a kind of amorphous silica product called silica fume from a resin perspective. In the next video, we will look through another amorphous silica product called fused silica. Thank you.